This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The first decision in trench safety is not which trench box to rent. It is knowing which rule has activated at the depth and condition in front of you. Reaching 4 feet changes the escape requirement. Reaching 5 feet changes cave-in protection and the project permit requirement. A dangerous condition can trigger protection even before 5 feet. Those are separate decisions, and merging them is one of the easiest ways to supervise the work incorrectly. A trench does not become safe merely because the crew has worked in similar soil before. Depth matters, but the condition of the soil, nearby loads, water, vibration, utilities, adjacent structures, and the way employees enter the protected area all matter too. California Title 8 puts one person at the center of those changing conditions: the competent person. A competent person is not simply the most experienced worker in the trench, and the title does not come from a degree. California defines the role through 2 parts. The person must be capable of identifying existing and predictable hazards, and the employer must authorize that person to take prompt corrective measures. That second part is the piece I want you to hold on to. Knowledge without authority is not enough. A superintendent may recognize cracking, water seepage, a damaged shore, or a worker stepping outside a shield. But if that superintendent has no authority to stop the operation and remove employees, the legal definition is not satisfied. I put the competent person duties into one field checklist. The person identifies hazards, has authority to correct them, inspects the excavation and nearby area before work starts, checks the protective system, inspects as needed during the shift, and re-inspects after a rainstorm or another event that increases the hazard. When a dangerous condition is found, employees must be removed from the hazardous area until the precautions are in place. The useful distinction is between a competent person and a qualified person. A qualified person may have specialized education, training, or credentials for design work. The competent person is the on-site decision-maker for daily hazard recognition and corrective action. The words are not interchangeable. Imagine a foreman who knows exactly why a trench wall is starting to fissure. He calls the office, leaves a message, and lets the crew continue while he waits for permission to stop. His knowledge may be excellent, but the authority part has failed. A competent person must be able to act promptly, not merely recommend action after production has continued. Now I want to separate the depth triggers cleanly. Think 4 feet, 5 feet, and more than 6 feet, but attach the correct action to each number. At 4 feet or more in depth, a trench must have a stairway, ladder, ramp, or other safe means of egress. Employees must not have to travel more than 25 lateral feet to reach it. That is an access and escape rule. It does not mean the protective system trigger is also 4 feet. At 5 feet or more, employees must be protected from cave-ins by an adequate protective system. That can mean sloping, benching where allowed, shoring or shielding, selected and installed under an accepted design method. A Cal OSHA project permit is also required before constructing a trench or excavation 5 feet or deeper when a person is required to descend into it. The shallow trench exception is not permission to ignore a hazard. Even below 5 feet, a protective system is required when the competent person identifies a potential cave-in condition. Depth is a trigger, not a guarantee of stability. The third number has 2 conditions. A walkway or bridge crossing an excavation requires standard guardrails when the excavation is more than 6 feet deep and more than 30 inches wide. I would not shorten that into a loose statement that every crossing at 6 feet needs guardrails. The exact depth and width conditions matter. A simple memory connection is this: 4 gets you out, 5 protects you in, and over 6 controls the crossing. Then add the exception that a competent person can require cave-in protection sooner. The 25-foot travel limit is lateral travel inside the trench. It does not mean ladders must be placed exactly 25 feet apart in every layout. The correct question is whether any employee position requires more than 25 feet of lateral travel to reach a safe exit. The project permit is another commonly missed layer. It is not the same thing as a local building permit. It is a OSHA safety permit, tied to the trenching operation described in the rule. A contractor can have approved construction drawings and still miss this separate administrative requirement. Protective system choices begin with the soil condition or with a deliberate decision to use the most restrictive Type C assumptions. California recognizes stable rock, Type A, Type B, and Type C in decreasing order of stability. When soil is classified, the competent person uses at least one visual analysis and one manual analysis. Visual analysis can include the soil particles, layered conditions, tension cracks, spalling, water, and nearby vibration. Manual analysis can include plasticity, thumb penetration, or a drying test. The important trap is visual confidence. Cohesive-looking soil is not automatically Type A. Previously disturbed ground, fissures, vibration, or other disqualifying conditions can prevent that classification. Old utility corridors and traffic beside the trench should immediately make the supervisor cautious about assuming the most stable category. If the competent person does not perform the analyses needed for a less restrictive classification, the excavation can be treated as Type C. That is a valid conservative approach. The code does not require every soil to be tested when the protective system is designed using Type C requirements. The slope table shows why classification matters. Stable rock can be vertical. General Type A uses 3/4 horizontal to 1 vertical, about 53 degrees from horizontal. Type B uses 1 horizontal to 1 vertical, or 45 degrees. Type C uses 1 1/2 horizontal to 1 vertical, about 34 degrees. Type C also does not permit benching. Water freely seeping from the soil is a Type C condition, and submerged soil belongs in that category. When water changes the condition, the original classification cannot simply be carried forward as though nothing happened. California also recognizes a short-term Type A slope of 1/2 horizontal to 1 vertical, about 63 degrees, for a trench no more than 12 feet deep and open no longer than 24 hours. Every condition matters. If the time or depth limit is exceeded, the steeper short-term configuration no longer applies. Suppose a crew cuts a qualifying Type A trench using that short-term slope and plans to backfill before the shift ends. A delivery delay leaves the trench open overnight. Before anyone re-enters, the competent person must reassess the condition and the protective configuration. The original plan does not stay valid merely because the soil still looks the same. For a quick field calculation, a Type C slope of 1 1/2 horizontal to 1 vertical means a 6-foot vertical depth needs 9 feet of horizontal run on each sloped side, assuming the simple Appendix B configuration applies. That is why soil classification affects space, estimating, access, and the decision to slope versus use a support or shield system. Sloping, benching, shoring, and shielding solve the cave-in problem in different ways. Sloping cuts the wall back to an allowed angle. Benching creates stepped levels in soil where benching is permitted. Shoring applies support to resist movement of the trench wall. A shield, commonly called a trench box, does not necessarily stop the soil from moving. It creates a protected zone intended to withstand the forces and protect employees inside. I put the methods side by side because the words can sound similar while the field function is different. The choice must follow an accepted design path. The configurations in the code. Appendices, manufacturer tabulated data, other approved tabulated data, or a design by a registered professional engineer. With a trench shield, the worker must remain inside the protected zone. A box does not protect a person standing outside its open end, walking through an unprotected section to reach it, or leaning into an area beyond the shield. The presence of steel in the trench is not the same as continuous protection. The sides of the shield must extend at least 18 inches above the top of the vertical trench wall. That extension helps keep loose material from entering the protected area. If the top of the shield is flush while a vertical wall continues to the surface, the installation does not meet that field check. excavation may extend as much as 2 feet below the bottom of the shield when the shield is designed to resist the forces calculated for the full depth. That is not a blanket allowance to suspend any box above any trench bottom. The design condition controls. Employees may not remain inside a shield while it is being installed, removed, or moved vertically. The operation changes the protected condition, so entry and movement must be coordinated instead of treated as routine production. Spoil piles, excavated material, and equipment must be kept at least 2 feet from the excavation edge unless a retaining device or another effective measure prevents material from falling or rolling into the excavation. That setback also keeps added surface loading away from the edge. A clean-looking trench box does not cancel the hazard created by a loader, pipe bundle, or spoil pile crowded against the cut. Water can change a trench faster than the schedule can react. Employees may not work in an excavation where water is accumulating unless adequate precautions are used. Depending on the condition, those precautions can include a suitable protective system, water removal equipment, a safety harness and lifeline, or other measures supported by the rule and the site plan. When pumps or other water removal equipment are used, the competent person must monitor the operation. If surface water can enter the excavation, diversion ditches, dikes, or other suitable means are used to keep runoff out. After a rainstorm, the competent person re-inspects before employees re-enter. Water is also a classification warning. Free seeping water points to type C soil. The field mistake is to keep using yesterday's soil label after today's rain. Seepage or pumping problem has changed the condition. Subsurface utilities require action before the bucket touches the ground. The Regional Notification Center must be advised at least 2 working days before excavation begins. The excavator must wait for the required utility responses and markings before starting. When the planned excavation is within 10 feet of a high-priority subsurface installation, the excavator and operator must meet to determine how the installation will be located safely. Examples include certain high-pressure gas lines, petroleum pipelines, pressurized sewage lines, and very high-voltage conductors. This is a coordination duty, not a reason to guess with the excavator bucket. Atmospheric hazards can also exist in excavations. Adequate precautions are required against oxygen below 19.5% and flammable gas above 20% of the lower flammable limit. Testing, ventilation, respiratory protection, and other controls depend on the hazard and the applicable requirements. A trench can have sound walls and still be unsafe to enter. Adjacent structures deserve the same attention. Excavating below the base or footing of a foundation is prohibited unless support, such as underpinning, is provided, or another condition allowed by the rule is met. Sidewalks, pavements, and nearby structures cannot be casually undermined. Their weight and loss of support become part of the excavation hazard. The daily inspection is not a paper exercise, performed once and forgotten. It covers the excavation, adjacent areas, and protective systems before work begins and as needed throughout the shift. It must be repeated after rain or another hazard, increasing event. I would organize the field check around changes. Has the depth increased? Has the crew moved beyond the shield? Has water appeared? Has spoil moved closer to the edge? Has traffic or equipment added vibration? Has a ladder been removed? Has the shield been damaged or lifted? Has the cut approached a footing or utility? Each change can invalidate yesterday's safe setup. Consider a hypothetical plumbing crew working inside an 8-foot trench with a properly installed steel shield. A hand tool rolls beyond the open end, and a worker steps outside the shield to retrieve it. The protection has not followed the worker. The correct supervision decision is to stop the exposure and recover the tool through a method that keeps the employee inside a protected route and work zone. Another common error is treating shoring and shielding as synonyms. Shoring supports the trench wall. Shielding protects the worker within the shield. That distinction changes what the supervisor inspects. With shoring, I look at the support system, spacing, installation, and soil response under the design data. With a shield, I also verify the employee never leaves the protected zone and that entry and exit remain protected. The safest memory is not a pile of disconnected numbers. It is a sequence of decisions. First, identify the competent person with both knowledge and authority. Second, verify depth and the separate triggers for egress, protection, permit, and crossing protection. Third, classify the soil or use Type C assumptions. Fourth, select an accepted protective system design. Fifth, control water, spoil, utilities, atmosphere, access, and adjacent structures. Then keep inspecting as conditions change. Here is the compact review I want you to carry to the next practice session. At 4 feet, provide safe egress, with no more than 25 feet of lateral travel. At 5 feet, provide cave-in protection and obtain the Cal OSHA project permit when a person must descend. Below 5 feet, protection can still be required when the competent person sees a cave-in hazard. For a crossing, remember more than 6 feet deep and more than 30 inches wide. A competent person has hazard recognition ability and employer authority to correct the hazard. Soil can be analyzed with visual and manual methods, or the system can use Type C assumptions. Type C slopes at 1 1/2 horizontal to 1 vertical and does not allow benching. A shield must extend at least 18 inches above a vertical trench wall, and excavation below the shield is limited to 2 feet under the stated design condition. Keep spoil and equipment at least 2 feet back unless effectively retained. Most important, do not let one correct feature hide another wrong condition. A ladder does not replace cave-in protection. A trench box does not protect a worker standing outside it. A soil label does not survive a change in water or vibration without reassessment. A knowledgeable worker is not the competent person unless that worker also has authority to act. I made an audio practice quiz specifically for this episode on trenching safety and protective systems. The questions are read aloud, and you answer by tapping, so it works for people studying while driving, working, or moving through the day. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about what I covered, and subscribe so I can help you stay on track through every episode until you get your license.